A background job scanned the entire orders collection with strong consistency reads, pinning the primary CPU at 100% while replicas sat idle. Latency spiked from 50 ms to 2 seconds, then timed out. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover PACELC Theorem. PACELC says, if a network partition occurs, you must choose between availability and consistency, just like CAP. But when there is no partition, the else case, you must choose between low latency and consistency. This captures the trade-off that affects performance every millisecond. CAP only applies during a partition, which is rare. The real cost is the latency versus consistency trade-off you make every millisecond when the network is healthy. Teams that ignore this end up with high P99 latency and lose to competitors using eventual consistency. Every distributed database sits somewhere on the PACELC spectrum. PAEL systems like Cassandra and DynamoDB favor availability and low latency. PCEC systems like Spanner favor consistency at all costs. PCEL systems like MongoDB default to consistency during partition but low latency otherwise, a dangerous mix. Here's how Cassandra classifies under PACELC. It's PAEL by default. During a partition, it stays available. During normal operation, it favors low latency. You can tune consistency per operation, but stronger consistency always costs latency. You don't have to pick one PACELC class. Most databases let you tune consistency per operation. For a checkout service, use strong consistency for placing orders and eventual consistency for order history. This gives you the best trade-off. Here's a real example in Cassandra. For critical writes like placing an order, we use local quorum for strong consistency. For reads like checking order status, we use one for low latency. This is operation-level tuning. PACELC assumes the else case is healthy. But what if a secondary has a slow disk? Writes with W, majority, wait for that slow secondary, spiking latency. The fix is to reduce write concern to W, 1, moving from EC to EL for those writes. In MongoDB, you can configure write concern per operation. W, majority, gives strong consistency but waits for replicas. W, 1 gives low latency but risks data loss. Choose based on criticality. Let's look at 3 production systems. DynamoDB is PAEL by default, with strongly consistent reads costing double. Cassandra is also PAEL, but with more tuning knobs. Spanner is PCEC, using true time for global consistency at a cost. In DynamoDB, you can opt into strongly consistent reads by setting consistent read to true. This costs double the read capacity units and has higher latency. By default, DynamoDB uses eventual consistency for low latency. Some vendors claim strong consistency with low latency. That's a half-truth. Techniques like Raft or TrueTime reduce the cost but don't eliminate it. There's always a trade-off. Etc. uses Raft for linearizable reads, but they still require a round trip to the leader. Serializable reads can be served by any node with lower latency, but may return stale data. 3 patterns: tune consistency per operation, isolate services by PACELC requirements, or use a hybrid with a strongly consistent database and a cache for low latency reads. I've used the hybrid pattern in a high-traffic e-commerce site. Here's the hybrid pattern. Product details are served from RIDIs for low latency, but inventory updates go directly to PostgreSQL for strong consistency. The cache is invalidated on write to prevent stale data. This is the same issue we highlighted at the start. Here's exactly why that happened. A background job started scanning the entire orders collection with strong consistency reads. Every read went to the primary, maxing out its CPU. Replicas were idle because reads never touched them. The checkout service timed out. The fix was to change the background job's read preference to secondary preferred, routing reads to replicas. Write concern was reduced to acknowledged for non-critical writes. Latency dropped back to 60 ms. Using strong consistency, for every read bottlenecks the primary. Route read-heavy workloads to replicas and accept eventual consistency where possible. Don't use all or each quorum unless you absolutely need global strong consistency. These levels wait for all replicas across all data centers, causing massive latency and potential timeouts. If you use W, majority, and one replica is slow, all writes slow down. Monitor replica lag and set a W timeout to avoid indefinite blocking. Even HBase, a CP system, can return stale data if you use a non-linearizable read like scan with read-all versions. Always verify your client's consistency level. Don't use a cache as your source of truth for critical data. If the cache goes down, you lose data. Always have a fallback to a durable database. A common misconception is that a database has a single PACELC classification. In practice, you can tune consistency per operation, effectively choosing different points on the spectrum for different queries. The article mentions this, but doesn't emphasize that the classification is per operation, not per system. The article discusses MongoDB's write concern, but doesn't show how to set it per operation. Here's an example of using W, majority, for critical writes and W, 1 for non-critical ones. The article touches on multi-region but doesn't fully explore the PACELC implications. In a multi-region setup, the else case includes cross-region network latency. Choosing low latency, EL, often means using local consistency, e.g., local quorum in Cassandra, and accepting eventual consistency across regions. This is a key production consideration. To diagnose PACELC-related issues, use these commands. For Cassandra, check read latency with Node tool. For DynamoDB, check provisioned throughput. For MongoDB, check replica lag with RS status. Let's run through some common interview questions. How does PACELC extend CAP? Adds else clause for normal operation. DynamoDB vs spanner for e-commerce. DynamoDB PA EL for catalog, spanner PC EC for payments. What happens with quorum during partition? Writes may fail, reads may be stale. And a few frequently asked questions. What does PACELC stand for? Partition, availability else, latency, consistency. How is it different from CAP? CAP only during partition. PACELC adds normal operation. Can you have both low latency and strong consistency? No, there's always a trade-off. Key takeaways: PACELC forces you to consider the latency versus consistency trade-off during normal operation. Use strong consistency only for critical operations. Most production issues come from ignoring the else case. Ready to go deeper? Up next, vector and Lamport clocks, then heartbeats and failure detection. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.